Welcome to my house. Welcome to the Structure Talk podcast, a production of Structure Tech Home Inspections. My name is Ruben Saltzman. I'm your host, alongside building science geek Tessa Murray. We help home inspectors up their game through education, and we help homeowners to be better stewards of their houses. We've been keeping it real on this podcast since 2019, and we are also the #1 home inspection podcast in the world, according to my mom. Welcome back. We are here with part 2 on spray foam installation errors, and we're getting an education on spray foam. We've got Tom Harris with us again. We're doing another podcast with him. Tom Harris is a spray foam guru. If you have not listened to episode 1 in this series, and I don't know, I shouldn't say it's a 2-part series. We'll see where this one goes. We'll see how much we can cover. we have to get Tom on another one. I don't know how much I can twist his arm, but please listen.
We're paying him a lot of money
1
to come on this show.
Oh, wait, now that needs to be edited.
We'll fix that in post, test. But yeah, we got
know
Tom on
we're
here
joking.
again. And Tom, let's just jump right into it. We left off last week. We were talking about a bunch of installation errors and all the things that need to be done right when you're installing the spray foam. And something I forgot to ask you when we were talking about it was, one thing you said is that you need to have a clean surface if you're going to be spraying spray foam. What does that mean, a clean surface? Does this mean you need to scrub down all your studs and your sheathing with TSP before you spray it on? What, define clean for me?
Yeah, it's a good question, Ruben, and we get that a lot. And basically, if you look at it as a paint, how would you prepare the surface for house paint? Well, you
scrub it down with TSP.
Would you really?
Maybe. Maybe.
So it's essentially a paint. I mean, you've heard of polyurethane and coatings, that shellacs that you would put on your furniture. Well, that polyurethane is the same chemistry as we spray, call it foam. We just put a blowing agent in shellac, and it's the same basic formulation. But from a surface prep standpoint, if you were going to paint a surface, you would want it, clean? Yeah, cobwebs in the corner and dust and that sort of thing. So wipe it, okay, or blow it with an air wand. A lot of these pieces of equipment actually have continuous air coming out the front of the tip of the gun. So the contractor would be standing there, not spraying foam, and there's air constantly coming out the tip of the gun just to keep it clean. Point it at the substrate. Get rid of the cobwebs, get rid of all of the scraps of, that have collected in the corners. Blow it out with the gun air. That's perfect.
Okay.
From things like metals, you wouldn't think to paint over rust. You'd abrade it, with a scraper or some sort of wire brush, and then blow the rust bits away. Same thing with foam. Okay. You wouldn't paint over a painted surface that's cracked and chipped and the paint's flocking off and all that kind of stuff. You wouldn't do that. Well, we wouldn't do it with spray foam either. So we'd prepare that surface. Now, metal is a little different. In some cases, you won't stick very well to metal, especially stainless. So we would recommend a primer. Now, we don't need it for things like OSB or typical residential construction materials, but in specialty applications like tanks, storage vessels, roofing, we get into the use of primers. And it's fantastic bonding agent. But typically in residential, we don't see that.
Okay. All right. Gotcha. Well, that helps. So you don't need to be able to eat off it, but you can't have a bunch of dust and dirt. It needs to be relatively clean. Okay.
Yeah, clean, dry, and supportive. It has to be structurally, have some integrity. You can't expect to string like Tyvek from stud to stud and then spray on it and have a perfectly flat surface. Not going to happen. Mm-hmm. There will be some deformation of the substrate. Now, you talk about the adhesion and the surface prep and the adhesion for foam to the substrate. You know, in Canada, every single contractor, every day, every change of batch of material, every manufacturer's different type of material, every change of direction of the substrate, they have to do an adhesion test by law.
Wow.
Wow.
We don't do that here.
What does an adhesion test look like?
Well, I'm actually, there's a group in the United States, and I'm a trainer for them and an auditor for them, called the Air Barrier Association of America. When we decided to call spray foam an air barrier and move into new construction commercial, a lot of that air barrier technology is applied to the outside of the building, sprayed directly onto dense glass or poured concrete or block concrete, but you're spraying in that cavity between the structural and the cladding. Now, foam is not perfect, but foam is great in this application because it's an insulation material, it's fully adhered, it's monolithic, meaning there's no gaps, cracks, seams, nothing like that. It's an air barrier, and it's a type 2 vapor barrier, and it's a rain screen. I mean, it doesn't get any better than all that. Into one material, and you don't have to cut and paste around things like brick ties or any of that sort of thing. So that group says, look, if you're going to call yourself an air barrier, you're going to do adhesion testing on every different substrate, on every different angle, every day that you perform your work on this job. And that specification is the Air Barrier Association of America installation specification. And it contains thickness and density measurements for spray foam and adhesion measurements for spray foam. And adhesion's the key. But we don't, very few, take that idea, that concept, and apply it to residential construction. We should, maybe. I mean, in Canada, they do.
Got it. Okay. So there's adhesion, and then something else you talked about that might impede adhesion, I guess, would be the surface temperature. That's got to be correct. What's a typical acceptable surface temperature that would apply to most manufacturers? I know you didn't like me using that word last episode.
Sure, Ruben, that's a good question. And spray foam, because it's engineered on the molecular level, we can make it perform at a lot of different temperatures.
Okay.
Imagine the difference between Arizona and Toronto, Ontario, or Winnipeg. The substrate conditions in Winnipeg rarely get above 80 degrees, but they do get to minus 20. So we have to formulate chemistry that works at minus 20. Now, we don't get minus 20 in Phoenix, but we get 130 for a surface temperature. That chemistry has to be different. The reaction speed of the chemicals themselves as they create urethane foam, we can, as chemists, modify that. We can slow it down when it's hot outside. We can speed it up when it's cold outside. Remember that when we mix the A side and the B side, it's what they call an exothermic reaction. Exothermic, meaning produces heat. So it's in itself, when you mix the A side and the B side, it's going to get hot. It's going to create heat on its own. So imagine a cold environment where that substrate that we've just put foam on is now sucking the heat out of the reaction. It's going to sag. It's not going to create good foam. The density is going to be off. It's going to be ugly. How do we overcome that? Well, we add more catalysts. And a catalyst is a chemical that controls reaction speed. We have catalysts in our resin that manufacturers make. And if we know what we're going to be making it in cold weather, we'll add more catalysts, maybe even a different catalyst. So that contractor regardless of the environment that he's spraying in, should not see a difference in the reactivity, the time taken to create good foam. It shouldn't sag, it shouldn't split, all that sort of thing. And that reaction temperature is quite substantial. If you take a 2-inch thick of closed cell foam and you take the core temperature, it can get upwards of 250, 280 degrees. That's hot.
Yeah.
So the substrate temperature is critical for that first pass. The surface of the first pass is now your substrate, and that temperature is critical for your application of your second pass. Okay?
Okay.
It's an insulation product. You've just put 2 inches of insulation on the OSB in a residential construction, and it's minus 20 outside. Now the surface of that foam is around 100. And you've got chemistry that you think is going to see minus 20. It's not. It's going to see 100 because it's insulated. So that can create problems of its own.
Okay. All right. So let me just make sure I understand this. So I'll kind of repeat back to you my understanding. You're saying that there's probably no improper surface temperature. There's just an improper mixture for that temperature, or
exactly right. You've got it, Ruben. Exactly okay. Right. And contractors need to be aware of the technical data sheet that's for the material they own.
Okay.
So there's a technical data sheet. Go ahead.
Sorry to interrupt you. Quick question. So how easy is it to adjust the chemistry of the product you're spraying? Because it sounds like you need a completely different chemistry or different amount of catalyst from one pass to the second pass. Is that an easy?
That's what they pay chemists for, and that's an interesting question. The chemists will design a set of chemistry that works from 50 degrees to 120. Substrate and ambient. Yeah, it's a different material. They'll call it winter grade or something like that for application in temperatures below 50.
Okay.
And believe me, 50 is not the magic number. It is formulation specific. It is manufacturer specific. It is for every single one. I had 7 different reactivity speeds, seasoned speeds for roofing foam.
How many contractors, though, are actually using all these different variations of the foam depending on the layer and the temperature of the substrate? Because I can't imagine that that's actually happening in the real world.
Well, it does happen. And what distributors see, if you're going through the distribution and distributor channel, they'll stock winter grade and summer grade. And let's say we don't have a fall. Let's say this particular manufacturer just has a summer grade up above 50 and a winter grade below 50. In the shoulder seasons, spring and fall, north of the Mason-Dixon line, he'll probably stock both. And the contractor will start the job in the morning with winter grade because that substrate is OSB, roof sheathing. It's exposed to the external environment, right? They'll do their best to bring that internal house under construction temperature up by using heaters and that sort of thing. And it might get up to 50, 60 degrees. But outside, it's 40. It's 35. I need winter grade foam because the substrate temperature, which you measure with a infrared gun, just the temperature gun.
Yeah.
It is likely somewhere around 45, maybe 50, even though you're trying to supply heat through different heaters to that indoor environment. So that first pass is subject more to the exterior, the outside environment. I want to use winter grade foam in the winter. So I'll go around the house and I'll do the whole thing with all this winter grade foam. When I come back, I know that that substrate is now insulation and is probably not the same as the cold outdoor environment. I'm going to switch to summer grade.
Okay, and maybe we're getting ahead of the listeners here because Tessa and I know about different lifts, but explain to us why you can't just spray 3.5 inches in a stud bay or just fill up the stud bay in one shot. Tell me why you need to do many layers.
Yeah, good question. And that technology has just come to us, the ability to spray what they call high lift. You might see it called HL or high lift or extreme or, XL, extra large, this sort of thing. And that capability hasn't been with us since day one. It's only a recent advent with HFO technology, this new blowing agent. So about 5 years ago, we started to switch the industry over, and we noticed that it's an exothermic reaction. Remember, produces heat.
Mm-hmm.
If you spray that more than 2 inches thick with the old technology, you start to see a discoloration through the center inch. And that exotherm, that temperature, remember, typically it's around 280, 285. That can get over 300, 320 in that range and start to actually char the foam. You thermally decompose the foam and it manifests. It shows itself as a charred, dark, discolored layer through the center of that pass. So we said, okay, well, no more than 2 inches, because that's fine. We know that's fine. You can do that all day. And everybody's technology was based on 2 inches, single pass, 2 inches. If you had 6 inches to install to get the R value, you're doing 3 laps in the attic per se.
Sure.
Okay, 2 inches, 2 inches, 2 inches, 6 inch total. Okay, great. Everything's fine. Off we go. And that's fine until you get this high lift material. So now we look at this beast of urethane foam and we say, how thick can I spray this new technology? And we're finding that we can actually spray foam in 3.5 inch, 4 inch, 5 inch, 6 inch, 7 inch in a single pass and not get discoloration or thermal degradation of the foam itself. This is fantastic news.
Open and closed cell. You're talking about closed cell specifically.
That's right. Specifically and only with closed cell. This is fantastic news. So remember our 6 inch attic? I don't have to do 3 passes anymore. Okay. I should only be able to do it in 1. Okay. That is so formulation specific that contractors need to be absolutely reading these technical data sheets. Each technical data sheet for each formulation will tell you exactly how thick you can do a single lift. Some are 2, some are 3, some are 4, some are 5, some are 6, some are 8.
It seems like to me this new technology would cut the cost of spray foam in half potentially because of the amount of labor you're saving, and you don't have to switch between a winter foam and a summer foam between the different passes and clean out your equipment and get all set up again. I mean, you just come in, you set up, you spray it once, and you're done.
That's the marketing theory. The technical theory. We become more experienced and experts, and I wish you wouldn't use that term, Ruben. Thank you. But I mean, others may, but expert. You gain experience through years of handling products, and our blowing agent, the one that had a greenhouse gas global warming problem, we had that in the market for 15 years. So we have 15 years of experience spraying that stuff. We know exactly how it handles. This new low global warming potential HFO stuff that we now have has been out somewhere around 3 to 5 years. We don't have the experience. And of course, the first people that get a handle on it to get to use it are the chemists and the technicians of the systems house, the manufacturers. And we played with it for years to find out what this stuff will and will not do. And we discovered you can spray a single pass without it thermally decomposing up to like 6 inches. This is fantastic.
Yeah.
All right. Well, that's a lab guy and a chemist. Lab's at 70 degrees.
Yeah.
Beautiful day. Nothing goes wrong. You take that to the field and say, okay, you can spray this 6 inches thick. And I'm only using 6 inches as an example, but you can spray it in a really thick single pass. And over time, we've found that, well, that might not be the best approach because the top of the foam will look like a loaf of bread. It'll suck in from the edges. The core density of a 6-inch pass is not 2 pounds. It's about 1.7, which is structurally less. There's less ability to not shrink, to resist shrinkage at that density. So as we're making a thicker pass, we're also creating a low density zone in the middle, which is susceptible to shrinkage.
Okay.
Right. Less
Now, we
dimensionally
know-
stable. Yeah.
Well, let's not get into
And
that
rigid?
one.
Okay.
Let's get
Not the
into
same
that
thing.
one. But so everything that's, our physics 101 back in high school taught us that everything that's warm and hot has a specific volume. When we cool that volume, it shrinks. Right?
Yep. Tracking.
Okay. Well, imagine a foam where it's this big of a fixed volume. You sprayed it 6 inches thick. And now we're going to cool it. That center core was at 285 degrees, and we're going to cool it to room temperature quickly. That puts a lot of stress because Mother Nature wants to shrink that volume. The foam says, nah, you're not shrinking. You're going to stay right where I built you within the first 5 seconds of creation. It's going to stay 6 inches thick. That sets up a stress. There's tension there. And remember the substrate? If the substrate's not perfect, it's going to pull away from the sides because of the stress of cooling.
Sure.
Okay, that's why you see foam shrinking away from studs. They don't have great adhesion to begin with, and the stress of cooling has created a problem.
Okay.
And that's how it relieves the stress. Now, 6 inches thick, bread loaves, if you will, kind of shrinks in from the edges at the top because it's just not strong enough to withstand those forces. How do we get around that? Well, we can spray it thinner. Let's spray 2 3s and see if that top 3 inches does the same thing. Guess what? It doesn't. A 3-inch pass is very stable. The density is very consistent. The edges do not pull in. Okay. Well, didn't we just invent this thing so the contractors only needed to do 1 lap? All right. Well, let's think about what contractors mean by 1 lap. Changing the location of the scaffolding, changing the locations of the ladder, all the way around this thing, that's a pain in the butt. I don't want to do that. All right. So then what you're telling me is you would like to spray 1 stud cavity, then the next stud cavity, then the next stud cavity, then the next stud cavity. Okay, now I got to relocate. That's acceptable. Okay. If that's the case, why can't we spray 3.5 or 3 inches in our first pass and come right back on top of it and spray another 3 inches? Don't move anything. Just stand there and spray.
Yeah.
That saves your productivity that you were referring to, Ruben.
Mm-hmm.
Now, if you cut the pass thickness down, our density distribution is much better. We're stronger foam. This is a good thing. And because we're spraying onto a warm-ish substrate, some manufacturers say, hey, I want that surface temperature to be below 100 or below 120 or below 80. It's formulation specific, and they've done the work. They know what that surface temperature needs to be before you put your second pass on. Okay? Because if you put it on when it's too hot, it'll blow it off. If you put it on when it's too cold, well, it can't get too cold because the indoor environment is, hopefully you've been adding heat to that cold house, and it's around greater than 50 degrees. So that's what they've now come to, that the application guide for that product is a different document. There's the technical data sheet that says you must install this at 3 inches plus 3 inches in order to get 6 inches. Please refer to application guide. In the application guide, and every product's got one, which the contractors need to be reading, it will say 3 plus 3 or 2.5 plus 3. Some companies have even gone to the extent of explaining and checking the relative humidity and the temperature of the environment, because they're seeing a difference depending on where you are in the country. If you're in Florida, your relative humidity is higher, and there's a higher risk of scorching the foam. So they cut the thickness down. So the same formulation sprayed in Florida will say 2.5 plus 2.5 plus 2.5.
Mm-hmm.
You take that same formulation and you go to Montana, it's different. You can go 3 and 3.
Mm-hmm.
And this is all about chemistry, Ruben, Tessa. That's all it is. But the contractors need to understand all this data is available, and they need to read it because it's important. And that's really where we've come in the last 5 to 10 years. I've been around in this industry for over 40 years, and I've seen denial come to, denial of I need education to a quest for knowledge by these contractors. The new breed of spray foam installers is very encouraging. They don't want to make mistakes. Where do I get the information? Where is it available? Where do I get training? Is always the first question of contractors. You mentioned the Spray Foam Worldwide group. I monitor that Facebook group quite regularly, and it impresses me that they have conversations around what they could be doing or how to improve or what to look for. It's a community of interest that is being developed that is seeking knowledge to do things better. 20 years ago, it was, how do I end around the code? How do I do it quicker? How do I do it cheaper? We're not like that anymore. We're more focused on doing it right. And that's encouraging.
Yeah. Yeah. And let me ask you something. And I know you're gonna say it depends, but on average, how long are you gonna need to let your first lift cool down or just sit before you can apply a second lift? What type of wait time are we talking about here, Tom?
Yeah. Most companies say a surface temperature of X. And it's been my experience that it gets there within 30 seconds, a minute.
Oh, okay. All right. That's much.
So you're still gaining the productivity bonus of not doing laps around the attic.
Okay. All right. Got it. That's helpful. And then I know Tessa's got a bunch of other questions that aren't quite so related to the application, but I just got one more I'm dying to ask you about.
Sure.
What about froth packs? you can buy these things at the store. You can buy them online. It's like a $200 froth pack, and it's basically 2-part foam. It's a DIY thing for every handy homeowner out there. And you got these 2 tanks, and you hook them up to a spray nozzle, and you go to town. You insulate your rim joist. What do you think about those things?
They make great foam. They make foam that meets their product standard, and it is good foam. It's small packaging, not intended to do a lot of insulation work. It's 200 board feet, and a board foot is a foot by 1 inch thick. 200 board feet is not a whole lot of foam. 600 board feet, still not a whole lot of foam. But that's a plural, what they call plural component. If you open that box, there's a can of A and a can of B. And that's exactly the same as our industrial size, if you will, 55-gallon drums or bulk or whatever. A side's A side, B side's a B side. And it's very, 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 very similar technology. But it's just supplied in a very small container through a non-heated plastic hose to a usually plastic spray gun. Okay. And it uses what they call external mix. The little nozzles that you get to stick on the end of that gun has a helical mixer inside of it. And that's what does the mixing. It's in our industry, we use internally mix spray heads, spray guns, and that forces the chemical together inside the gun. In Froth Packs, which is by and large the same chemistry, we use external mix because we don't have heat, we don't have pressure. We've got very little pressure. So we need something else to add energy to the combining of the two materials. And we use what they call a static mixer. And that's what makes the chemicals come together and spray them out. But from a foam quality standpoint, it's very good stuff.
Okay.
Now, that's plural component. That's 2 cans, plastic hose, plastic gun. You have another option, a single component can that uses a different gun or a straw, and you spray that around your doors and windows. Mm-hmm. That's different technology. It's called single component chemistry, where they get that chemistry to almost work. When you put it in and apply it or install it through that straw, it's relying on the moisture that's in the air to cure it, to make it hard. And it takes a long time, especially in a dry climate. So if you ever want to move on and get this thing locked in, you put that single component can foam into and around the window and spritz a little water on it. That'll cure it up pretty quick.
Okay. Interesting.
But yeah, the chemistries are quite similar. The resultant product, very similar.
Okay. But you don't have huge concerns about surface temperatures not being within spec, because it sounds like it's critically important.
Have you seen and read the box?
I have not.
There's a lot of instructions on their packaging. There's a lot of ways to bugger it up. They have the same substrate requirements, the same temperature requirements, the same PPE. Yeah, still got to wear it.
Okay.
And the chemistry is quite similar, but the application is low pressure versus high pressure, which is what we use.
Okay. Well, I feel like I've hogged enough questions. Tessa, let me give you a chance to ask a few here. I'm sorry.
My brain is about to explode right now. I have so many different questions for you, Tom, and I'm trying to decide what direction to go. But I think one thing that's just kind of at the forefront of my mind after having the discussion about kind of how you've seen the industry evolving over the last few years and talking about, this spray foam worldwide and, Bill Bilbin starting this group of, thousands of contractors that are now communicating ways to improve, methods, strategies, installation, all of that, efficiencies. I guess one of my questions is some of that driven by pain that this industry has felt over the years with major failures. And we've talked about, all the different ways that foam can fail, and and it does, and it happens frequently. And I know you've seen that a lot from your side of things, and especially now being in the consulting world, and my past too of working in the spray foam industry, running across improper, foam installs and issues with that. And today too, I'm still seeing that people, contacting me about spray foam issues. But one thing we haven't touched on today is the potential for off-gassing and the toxicity of foam. And I'm wondering, is that still a problem? And if so, what makes that an issue, and what do you do about it?
Yeah, it's a good question, and one that we face every day. I just want to circle back for a second, Tessa, and I don't want to say caution you, but remind you that consultants, yourself, myself, anyone else that's in this industry, they only call us when there's a problem.
Yeah.
There are millions of homes since the mid-50s every year being installed with urethane foam as its insulation package.
Yeah.
Meaning where you and I live, it's in the code. Thou shalt use spray foam in every house. So from a I see it failing a lot and all this sort of, that's because I'm a consultant. I don't get too many calls that are going to pay me to come out and see a glorious job.
Yeah. Thank you for bringing that up. Yes, that is very true. The perspective I'm looking at is definitely glass half empty on this. For sure.
And the big home builders, the production home builders, we have tremendous market share as spray foam insulation in custom build. Anything that's design build, one-offs or less than 50, less than 100 builder, those guys prefer urethane foam. It's the production builders where we're just making inroads. Meritage Homes, for example, big builder. They only build in the South, and they use exclusively, all they use is spray foam. And that's a big production builder.
Wow.
Yeah, it's encouraging. So if there was a problem, we'd know about it. We only know, because we're consultants, about the problems because we're consultants.
Mm-hmm.
And hopefully that part of my business will go to zero here next year. So let's
I like your optimism. Yeah.
Very optimistic.
But it's interesting. You get, as a consultant, you get a little different perspective. I spent a lot of time as a manufacturer, contracting, that sort of thing. But as a consultant, you get to hear both sides. And homeowners, I don't want to say frequently, but there's a lot of my calls deal with the issue of odor. And what is odor? Well, odor is something that really our industry shouldn't be worried about at all. Because to install urethane foam, the common industry practice, best practice, recommendations from every manufacturer, and it's on the technical data sheet, is to isolate and ventilate. I just did a presentation at the Spray Polyurethane Foam Alliance Las Vegas convention on the issue of off-gassing, isolation, and ventilation. Contractors need to establish a work area, and it needs to be not quite airtight, but it needs to be not the house. So if you're installing foam in a retrofit application up in the attic, and you don't think your overspray or particles that are in the air is going to go anywhere, you're wrong. It's going to go everywhere. So isolate the workspace with 6 mil poly and ventilate it in order to address the airborne MDI, the odors, the particulates. Get them out of the house. So if you have to supply 65 CFM or 600 CFM to the work area because it's a big work area, then you exhaust with 10% more. So you've actually got a little negative pressure in your work area. And that means all of the airborne contaminants that are in the air during the application and for 24 hours afterwards need to be ventilated. If they are, foam has completely inert at that time. Nothing's happening to it. You're not applying the product, so you're not adding more shit to the air.
Mm-hmm.
That's a good thing. And those odors have been dealt with. They've gone away. They've been controlled. They've been exhausted out of the work area, therefore out of the house. So if you're spraying foam in an attic, what is your work area if you don't isolate that? It's the entire house. So if you've got a second trade or somebody sitting in the basement 2 stories away from you, maybe 3 stories away from you, and you think it's okay for them to be there, that's wrong. You've identified by not isolating the entire house, the entire structure, the entire Quonset hut, the entire barn dominium as your work area. Therefore, you need to take all the air in the work area, which is now the house, and ventilate it 600 times a minute. That's a lot of air, and you don't have a jet engine big enough. So contractors need to isolate the work area, and that will address odor and MDI exposure during the application, as well as the odor, not the odor, but the particulates in the air. I can't tell you how many times I've been in an attic with a hatch, and in order to get up to that top floor, there's a handrail, which is conveniently located right beside the attic hatch. And I've ran my hand up the handrail, and I've got MDI exposure. I've got particulates. It's gooey. It's sticky. It's overspray from spray foam because the contractor did not isolate. And that's a problem. The moment we pull the trigger, if we don't ventilate and create that negative pressure working environment, we're going to push that overspray, that odor, those contaminants through the hatch into the house. And it's going to land on the carpet. It's going to land on furniture. It's going to land on things we touch. And that's a problem. So isolation and ventilation is a requirement in the industry for proper installation. Every single technical data sheet will tell the contractor how many hours he has to wait after he's isolated and ventilated for so many hours, how long he has to ventilate the workspace to allow workers, it's called re-entry, to allow workers into that area not using PPE. And it'll be 2, 4, 6, something like that. But it'll be on the technical data sheet under so many CFMs of exhaust. There'll be a second statement that says reoccupancy. And what reoccupancy refers to is occupants of the home, the elderly, babies, chronically ill, the whole family. How long do you have to ventilate in order to rid the home of all of the things we've just put into it before they can reoccupy? And that number is typically 24 hours under ventilation. So if I do an attic, I have to isolate the workspace, ventilate it for 2, 3, 4 hours before the electrician can come back in. I have to continue ventilation for 24 hours if it's at the end of the job and I want the homeowners to come back in. That's 24 hours under ventilation. That's the important thing. When you finish the job, you can't stop ventilating. You can't take your blower and your exhaust and go home. You have to leave it there for 24 hours.
Yeah.
And that will address the odor issue that that we commonly hear.
So that's really interesting. What I hear you saying is that, if the installer is following the manufacturer's specifications and doing it properly, then you shouldn't have an odor problem. But what happens if you've got an installer who's not following the directions, hasn't read the material safety data sheets or the application, guide, and let's just say they haven't mixed the foam properly? Is there a potential for off-gassing, through the life of that foam then?
Well, it's interesting you use the term off-gassing and through the life of the foam. All foams are tested for VOC in the United States. In Canada, the test is a little different, but it's still with the same intent. What we have here is a product that we manufacture on site. The act of creating foam, we put particles of stuff in the air. That needs to be, our workers need to be protected with proper PPE. Under no circumstances should we expose the work area during application to non-protected people. After that foam is installed, we say 24 hours of constant ventilation. Now, we're not installing the product. That clock doesn't start until we stop installing it. So for 24 hours, continuous ventilation. There's the assumption there is that that product we've just finished installing is hot. Mm-hmm. It's releasing stuff into the air. Mm-hmm. A proper test, the VOC test, identifies for the manufacturer how long it takes for that chemistry to go to zero.
Yeah.
Okay. With that number, they pick a number of hours. And the industry pretty much unanimously has said 24 hours.
Okay.
Okay. So the assumption is that the chemical is inert, no longer off-gassing after 24 hours. Now, it gets interesting when you start to differentiate between chemical toxicity and exposure and all this sort of thing. That's an EPA and OSHA thing. And odor. How many people like the new car smell? Everybody does. Ooh, I love that new car smell. And they wind up the windows. There I go with my age again. Nobody winds the window anymore. The windows are closed. Everything's great. And I love that new car smell. That happens to be polyurethane that you're smelling, and some other off-gassing materials. Yeah. It's not a good thing. But you're tightening up the building envelope. Mm-hmm. You're taking air changes from, let's say, 10 to 12, 15, maybe down to like 3 to 5. Mm-hmm. That building envelope is now tight. You're going to smell things in that environment that you've never smelled before. And they're going to last. That's why we have HRVs, ERVs, monitors, indoor air quality monitors. That's why this whole thing, as we trend as a building science and an environmental, energy conscious nation towards reduced energy consumption, we talk about HVAC. Right? We want to reduce HVAC, so we right-size the things. So if I've right-sized my house from the 1970s, that engineer, that HVAC guy, based his calculations on so many air changes that house is going to go through. And he's right-sized the HVAC to accommodate that. Okay, I want to save some money on my HVAC. My energy is costing me too much. I'm going to insulate. I'm going to seal her up. I'm going to go from 10 to 12 air changes down to 3 to 5. I spray foam. That's great stuff. It's an air barrier. It's great insulation. I'm going to tighten the building envelope up. That's great. And I don't tell the HVAC guy I got a problem because my HVAC is not going to run. Yay, I save money. No, the indoor air quality has just been affected. We are no longer, in that case, taking the indoor air and running it across condensation coils for cooling. We're no longer circulating that air. We get a lot of dead spots, and they smell like dead spots because we're not circulating, because we've saved money on the HVAC side. It's not running as much. It's not circulating the air as much either. So when we retrofit, we need to understand the impact we're having on air quality, air changes, air circulation, and get back in touch with that HVAC guy and say, I've just tightened the building envelope up from wherever it was built at and whatever you used in the original calculation down to 3 to 5. And they can test this with a blower door and all that, ResNet and all that kind of good stuff. But if you're not working in concert with your HVAC guy, if you've only talked to the insulation guy and he's tightened the building envelope up, you need to understand that you've affected. It's the house as a system concept. You affect one thing and you do one thing and you've affected something else. You've now affected the HVAC and the circulation of air. And that can be a problem. And that's where consultants like myself get these questions on, I smell something. Yeah, well, I don't want to tell you what that is, sir, but it's not foam. Yeah, and that's where that's coming from.
I'm glad you touched on that, Tom, because it is very important to understand, the house is a system, and when you change one thing, you impact another. But it's what I hear you saying, though, is that if foam is applied properly, after that 24 hours, most manufacturers say that it should not be smelling. It shouldn't be putting off a smell anymore. Correct?
Yep.
Okay. So are there possibilities where it could still, though? If let's just say you do a pass that's 6 inches thick,
that's right,
and it cooks it from the inside out. I mean,
you're a building scientist now, Tessa. You completely understand. That's correct. When you misapply outside the parameters of the technical data sheet or the application manual, when you make a mistake, there are consequences. So if you applied a product that was only supposed to be installed 2 inches thick and you pounded it in at 4 inches in a corner, and it will thermally degrade. And that odor smells like fish. You've heard that fish smell. It smells like something's burning.
I've smelled that smell before.
Yes, and that's a problem from that thermal degradation.
The solution is you won't see it, but you'll smell it. And the solution is to remove the foam, right?
Correct. There's no bringing it back.
Yeah. Okay. Ouch.
Now, the other one that you occasionally get is poorly mixed chemical. We use pieces of equipment that provide a perfect 1-to-1 ratio, assuming you supply the chemical to the machine in the proper manner. The term is called cavitation. If you don't supply enough A side or B side to that pump that's on the machine, you'll get an airlock in there. Now, these are high pressure machines, 1200 PSI. You'll compress that air into the fluid and it'll move along the hose until it gets to the gun. So you've got 1200 PSI of side A and 0 side B. You get a splash of A side. Now, it happens so quick that it doesn't come out as a pure chemical. If you're spitting pure chemical out of one or the other chemical out the gun, for God's sake, you're going to stop spraying and find out what's going on. But the tricky bit is when it's pulsing, when you're only cavitating on one side, and it happens so quick you don't see it necessarily, but you can feel it. The actual gun actually pulses. The pattern changes. You can spray that on a wall, and if you just looked at it, you could barely tell. I'd be surprised if you could tell. And that's a problem, because it will smell. If you spray straight A-side or poorly mixed and it's resin rich, it'll smell like fish. And there's no estimate on when that off-gassing, to use your term, Tessa, there's no saying when that'll stop.
Yikes.
Because we haven't done the testing on poorly mixed foam.
Yeah.
Right. No.
We're not spending millions of dollars on things that are done wrong.
Yeah.
Yeah.
We've spent enough on things that are done correctly. And if it's done correctly, it finishes in 24 hours. You could bugger it up and it can go on an undetermined length of time.
Tom, you are just, this discussion is so fascinating, and I'm learning so much from you, and hopefully this is helpful for our listeners too. I think spray foam is just expanding, and as you said, I mean, we've got these, national builders, especially in the South, that are using spray foam in all of their homes these days. So, if our audience, we've got a lot of home inspectors that listen to this, we don't have any formal training on how to identify properly installed, or mixed spray foam. And so this is extremely helpful. So thank you for sharing all of this, your time and your wisdom with us. We really appreciate it.
You're very welcome. And actually next month I'm running in the Pittsburgh area, a training, 3 hours of training, and we're going to go out in the parking lot and spray some foam. And then we're going to go to job sites and look at foam jobs in the area for 50 building code inspectors.
Oh, wow.
So I would encourage any building code inspector to get their locale together, a few of the guys in the office, some inspectors in a room. And, I could come in, a number of consultants in the industry, we can come in and help train you.
And if people want to learn more about this, how can they find out more about this, Tom?
Well, I would suggest contractors and everybody Google the manufacturers. Go to the Spray Foam Trade Association.
I'm talking about your training.
Well, I don't want to shamelessly promote, but I've got some educational things on my website at letstalkpur.com that may be interesting for folks.
Okay, excellent. And that's
very helpful. And we didn't even get to talk about hot roofs today, Tom. So I'm praying that we can have you back another time at a future date. We can talk. We can dive into this a little bit more.
Yeah.
I'm looking forward to it. Sweet.
Well, Tom, thank you so much for your time. Listeners, if you got any questions, maybe if we end up getting Tom on for a part 3, I'm not going to promise we'll even get to your questions. That might be a part 7 or something down the road. But,
send us your questions if you have any.
You did. Yeah, Tom said maybe we should do a series. And I thought, well, let's just start with part 1. But I see what he was talking about.
Right.
I get it. But if you want to email us any questions, you can reach our podcast at podcast@structuretech.com. Feel free to email us. Tom, thanks again for coming on. I'm Ruben Saltzman for Tessa Murray, signing off. Thanks for listening, everyone. Take care.